Hey everyone, it's David Bombal coming to you from Oxford in the United Kingdom. I'm on a call again with Hank Preston, who's based in the States. Hank's got a surprise this week for us. He's going to talk about something relating to programmability and network automation. Hank, welcome to the call again.
Thanks, David. I appreciate it. And we won't keep the surprise hanging too long. We're going to dive into some programmability options on Cisco's Nexus switches, which is one of the first platforms from Cisco that really embraced programmability. And that means it has a whole suite of different options that you can dive into and take advantage of when you're using your Nexus switches.
So just for people who don't know, can you give us like a 30-second, what is the difference between classic iOS, if you like, and Nexus, where the positioning, kind of how they're different kind of thing?
Yep, sure thing. So classic iOS, the one that's been around for decades at this point, was kind of built and focused around campus, WAN, enterprise. And that wasn't to mean that it wasn't ever used in the data center. The Catalyst 6500 was a hugely popular data center switch as it went through. But man, I think it was about 8 years or so ago now, 7-8 years or so ago, Cisco started to take a firm look kind of at the changing dynamics and requirements inside of the data center from the network. And so they set out to build kind of mission-specific infrastructure focused on the data center space to kind of hit the requirements that data centers had, maybe pull away some of the requirements and things and not focus as much on elements of network features that didn't necessarily belong or weren't being used in in the data center, but were needed in the campus. And so that's where the Nexus line of switches and infrastructure came out of, was this kind of focused effort around data center network construction and building. And so it was in the Nexus series of switches where things like fiber channel over Ethernet came out, some of the early VPC or virtual port channel technologies came through, OTV for data center interconnect at layer 2. These were all features that had a place in the data center, and they were developed as part of the Nexus operating system, or NXOS, which is that data center specific, kind of mission specific operating system inside the network from Cisco.
Yeah, so I mean, I think we've briefly mentioned it before. So just to reiterate, classic iOS has been around for years. So you'd have that on like 2950s, 3750s, even older switches. That had a problem in that it had IPX and Apple Talk and who knows what else running inside of it. And then, I mean, we kind of alluded to the thing on a previous call that it's sometimes easier to start again. You mentioned like the 6500s had all this old technology that perhaps wasn't relevant for a data center. So if I understand right from what you've said then and now, Cisco kind of took a new look and created this specific operating system that I believe is more open based on Linux. Is that right? I'm just throwing things at you, Hank. So let us know what you think. You know, how's this positioned? How's it better than, say, classic iOS?
So classic iOS has actually evolved into iOS XE. And so it was this evolution that happened in the background that went from the monolithic single binary approach to delivering a network operating system to one built on top of Linux with processes and a modern development framework. And so what we think of as classic iOS switches today, things like the Catalyst 9000 or even some of the Catalyst 3850s and those pieces and 4500s, those have been running on top of iOS XE with a Linux underpinning for years, similar to what Nexus has been doing from the get-go. And from a maturity standpoint, Nexus OS has been out for, as I mentioned, 7, 8, even more years than that if we take in where it actually came out of, which was SAN OS. And so the underpinnings of NXOS, or Nexus operating system, actually came out of SAN OS, which was the operating system developed for Cisco's SAN switches, the MDS switches for fiber channel. And so because the fiber channel started out in the data center and it had some of the resiliency features and inline feature patching and things that were necessary for the data center, when the Nexus line of switches as an Ethernet switch as opposed to a fiber channel switch for the data center came out, that built on top of that SAN OS baseline. So that both platforms have been out for years. Today it's more about kind of positions in the network and the types of feature sets that you're after, whether it's an iOS or we still say iOS, but more often than not, it's iOS XE base switch or an NXOS base switch. And then Cisco also has the third platform, iOS XR, which, similar to how data centers have a unique set of characteristics and requirements that it has compared to enterprises, so do service provider and these very large networks, where iOS XR, kind of this very the specific platform and the hardware that's kind of based for those service provider networks, or very large enterprises that build elements of their networks that look like service providers. And so that's why we have iOS XE, NXOS, and iOS XR as kind of three separate platforms. Each one of them, there is some overlap in features, right? Routing is the same across all of them, but specific underpinning features, elements and things that you need in the data center sometimes don't necessarily need in the campus. And then the scale and some of the elements that service provider networks need, you don't necessarily need in either the data center or in the campus, which is, again, why we've got the three platforms. Cisco strives to have networking solutions for just about any type of network that a customer might have.
So again, Hank, sorry to hop on this, just to make sure that everyone who's watching, has a foundation. We've got iOS XE, so 3850 switch would run that. That's for the campus, is that right?
Correct.
And then you have, can you give us some examples like a Nexus type device and a XR type device?
Sure. So in the Nexus platform in the data center, we actually have a wide range of different platforms that are there. And so today we've got the Nexus 3000 and 9000 series switches, as well as some of the kind of the previous or the initial generation of the data center switches, which would be like the Nexus 5000 and 7000. They all run Nexus OS or NXOS. And different variations of those. Cisco's ACI platform inside of the data center, we've talked about that a bit in the past. That also, the switches run Nexus or NXOS operating system on those as well, and those would typically be Nexus 9000s. The 9000s can operate either in ACI mode or standalone mode. We're going to focus on standalone mode today. And then the iOS XR platform, these would be the ASR 9000 switches, the NCS switches, different platforms like that.
That's great. So, the Nexus devices focus mainly on data center. Is that correct? It
is. You'll occasionally find customers that use them as distribution blocks inside of campus or WAN or other specific areas where they need some feature set or the Nexus platform made sense versus a Catalyst or something else. But typically the Nexus switches would be found in a data center.
And I think one of the reasons, I'm making a presumption here, which is always dangerous, that one of the reasons we're doing Nexus in this call is from what you've told me previously, they have good APIs. Or from a programmability point of view, it's very rich what you can do with them. Is that correct?
Yeah, so for this call specifically, I just happened to pick Nexus. I imagine we'll hit some of the other platforms in other calls. But as I mentioned at the start, inside of the data center, from a networking perspective, it was one of the first areas where there was a lot of pressure from many customers for programmability features. There's a variety of reasons why the data center seemed to be one of the early places that went through. And so the Nexus NX-OS has had programmability features probably for the longest, or I'm less familiar with XR, so I'm trying to hedge my words a little bit, but certainly has had a lot of these programmability features longer than iOS or iOS XE, which means it does have a robust set and range of different programmability options. And one of the things that I wanted to take some time when we get into it today in our call is to kind of walk through the evolution of programmability, because I love the Nexus talking about programmability when you're working with a Nexus switch, because you can kind of see the evolution of the SDN thought process and requirements by looking at the different interfaces that NXOS offers, because it's kind of evolved along with the demands of programmability and SDN from customers. And so we can kind of see them all in one single platform. And it also is a great platform for engineers trying to figure out how to get into programmability, because you can start with different interfaces and kind of work your way up to them as your individual requirements and your individual skills start to change and evolve.
That's brilliant. Really looking forward to it, Hank.
Excellent. Perfect. So with that, what I've got here sharing, or what I've got up on the screen, is a Nexus, virtual Nexus 9000 switch. And as is typical, I just grabbed one of our DevNet sandboxes. So I'll just kind of show if anybody wants to dive in and do something similar later. I've reserved what we call our Open NXOS with Nexus 9K sandbox. It's a reservable instance, which means I get one dedicated just for me. We'll include a link to this inside of the show notes for this one. And you can see once I've reserved it, up here normally it says reserve, it says active because my reservation is active. It goes ahead and spins up, and inside of this particular sandbox I get an NXOS switch, and then I also get what we call our tool server or a dev box, which is a Linux server loaded up with Python and a bunch of other utilities that you can use if you don't have all of those things available on your own workstation, or you're just looking to get started quick. We kind of give you a nice little dev box to get going. And then at the end of the reservation spin up, you get an email, but it also shows up here inside of the web interface with the VPN credentials. So you can VPN into this sandbox pod and have access to the resources that are there. And so we can see my switch here is 10.10.20.58, and the credentials for everything are shown up there. And so this is what I've reserved. I reserved it before the video, so we didn't have to wait the 6-7 minutes for it all to spin up. So I've got that ready. And so over here, we can see I've got my switch. If I do our typical show version, we will see that this sandbox is running on the latest version of NXOS, so 9.2.1. I will try to call out when there's a specific programmability interface that showed up recently or in a particular release, but a lot of the stuff we're going to talk about has been around for many, many versions. So you don't necessarily need to be on the latest version of NXOS to take advantage of some of the features we're going to talk about today. But there are some cool new features that are added every release, particularly in the programmability space. And so it's always good to try to stay on a recent release if you're looking for some of these new features that are there. I'm going to pause for a second. Any questions? Anything that I've kind of skimmed over real quick that may not have been as clear yet, David?
No, I'll just emphasize, I've used one of these sandboxes before. Firstly, it's free because it's DevNet. So for anyone watching, it's free. And if I remember right, Hank, you just have to download a VPN client, and then it's all provided to you. And then you just access it across the internet. And then basically you've got a VPN connection into DevNet, and then you've got full access to these devices for your reservation period.
Yep. Exactly right. And the VPN client is either Cisco's AnyConnect client, which you can download for free just by trying to connect into the piece, or you can also use the open source OpenConnect, which is just an open source VPN client that supports Cisco's protocol on that. Either one of them work. I happen to be using AnyConnect for now, but I use OpenConnect pretty regularly as well, depending on what my needs and use cases are on that. So
that's great.
All right, so I'm on my switch. So when you first spin up your reservation, and I built this sandbox, so I'm pretty familiar with what's inside it. We've kind of prepped it for a programmability perspective. So if we take a look real quick, so I'm going to do a show run. So show running config, and I'm just going to include feature so that we can take a look at the features that have been enabled, because programmability is a feature inside of the Nexus switches. So the different interfaces are available. But in general, on the Nexus switches, anything you want to do as a network protocol or network capability, you have to enable it as a feature, with the idea being that we don't want to turn on things that you don't necessarily need to use, because every feature that you have on inside of a switch is a process that's running, that's taking up memory and CPU cycles. Even if you're not configuring it, it's still there in the background, and you expose yourself to different potential bugs and software issues. So the general idea is don't turn something on if you don't need it, which is where the kind of the feature mentality around Nexus comes from. And so we can see there's several features that are on. We're going to go through a lot of these. So feature NXAPI, this first one at the top, is a group of APIs for Nexus switches. And we're going to walk through kind of the different options that get enabled when you take a look at NXAPI. And this is the web version, the HTTP, the REST APIs, kind of the things that run over web protocols. All of those are grouped underneath NXAPI. We can also see I've got feature bash shell turned on. And so as David, you mentioned before, Nexus NX-OS is a Linux application that runs on top of Linux. iOS XE is the same way. But what we see here is the ability on NX-OS switches to actually get outside of the running Nexus application, which is the network operating system, and connect directly to the underlying Linux bash environment. You can turn on access to that. Oftentimes you don't necessarily need to get into it, but if you want to, if there's something that you need to tweak, or there's certain features and things that you need to take advantage of, you can just turn on feature bash shell to get access to the underlying bash shell that's there. Some of these will look familiar. So SCP server for copying up and down files, OSPF and BGP, so that you can do some routing. There's some base configuration that we lay in here. And then down here we see the group of model-driven programmability interfaces have been enabled. So netconf, restconf, and gRPC. We've talked about, I think, all of them on previous videos and gone deeper into some of them. But the Nexus switches support netconf, restconf, and gRPC that's out there. And then this last feature that's here is interface VLAN. That's just, again, turning on the ability to create an SVI or interface VLAN 101, something that you might need in a distribution layer switch, which is kind of what we've simulated that are in here. And you can also see that there's some, it looks like some SNMP stuff kind of showed up in this output that's there. So, it showed up because features in the name of these ones the way that I did them there. So, any questions on the features that are there, David?
No, that's great. It'd be nice to see that. I don't want to interrupt your flow. It'd be nice to see that bash shell at some point.
Yep, we absolutely will. It's on the things that I'm hoping to kind of get through as we go in. Right. So as I mentioned, Nexus OS, I love teaching with it, teaching programmability with it because of this evolution that it shows and it underwent under the hood. And one of the earliest ways that network engineers and enterprises kind of wanted to have programmability access was fairly simple. They wanted to be able to send CLI commands to a device over an interface that was other than just trying to like script SSH or telnet sessions, which we've all done forever. I mean, most network management systems, even still today, that's how they work, is they programmatically stand up a telnet or SSH session, and then they send a bunch of commands, and then they listen to the output, and then you have to process it at the end. And that was functioning, but many customers, particularly as programmability in other spaces and APIs came up, is they're like, we're tired of having to kind of self-manage show commands through an SSH tunnel. Can't we do this over HTTP or something else? And so this feature NXAPI is the first one we're going to dive into, was kind of born out of that type of a demand, is we wanted a way to easily send CLI commands and retrieve data, the output back for processing and not have to deal with SSH. And so we turn on feature NXAPI, and under the hood, what that does is it jumps into and connects to the embedded HTTP server that's on NXOS, and it offers up some HTTP style APIs that are there. And there's actually several of them, and we're gonna walk through them. One of the first things that is good to do when you start playing with feature NXAPI is just navigate to the IP address for your switch. And so in this case, my switch it's probably really tiny on the recording, but 10.10.20.58. Remember, we got that out of the Sandbox piece. And then just HTTPS. Let me see if I have time down here. Yep. So what you'll do is you're prompted for the credentials. And so just switch credentials. In our Sandbox case, they're admin and then Cisco 123 with a capital C. And there we go. And I'm getting some warnings about Flash. There's elements of this Sandbox thing that we're looking at here that sometimes can use Adobe Flash under the hood. You don't need Flash enabled. And as you can see, I don't have it enabled here, so we won't be using any of those specific features. I'll point out where they are, though. And so what we've got is what's called the NXAPI Developer Sandbox. And it was designed originally to help network engineers ease this transition into programmability and take advantage of NXAPI that's there. And so what you see at the top here is a place to enter a bunch of CLI commands, and then it'll be those CLI commands will be turned into a request block. And so if you remember any of our conversations on REST APIs or any HTTP style API have two objects: a request object that the client sends out to the end device, and then the end device sends back a response object. And so what we'll see in just a minute is this request block gets auto kind of created to show what the request object would have to look like. And then you'll have the ability to send that off and see the response that comes back from the switch. And so this is like a really lightweight API client for experimenting with what's there. And so we'll send our first one, and we'll just do kind of a show VLAN, and we'll say brief. Show VLAN brief. So typical kind of show me my layer 2 VLANs. And so down here in the request block, we can see, okay, this is what the HTTP request would look like to send this. And we'll actually see how we can send this using another tool, Postman, in just a second. But we don't need that just to try it out to see what it would look like. We can see that this hopefully looks familiar for folks that have kind of watched some of our other videos. This is a JSON block of data. And we can see here it's indicated as JSON RPC 2.0. And so what JSON RPC is, it's actually a standard API messaging format. So the RPC at the end stands for remote procedure call. And the way I always describe RPCs is it's just a fancy programming word for, hey, I'm going to ask some other remote system to do something. Let's call it a procedure, and then tell me back the results of the data. And so JSON RPC is just a way to send these types of RPC messages in a standard fashion from a client to a device. And so we can see the method of this RPC is a CLI block of data. And then inside the params is where we actually kind of, the client would send the interesting bits of information for this RPC. And so what we can see is we're just embedding the command we want to send. Show VLAN brief, version 1. The JSON RPC specification says you have to say send a version piece, so just version 1 gets put in there. And then the ID message is kind of how the RPCs are linked back and forth. So when we get a reply back, we'll know, we know how to link them up. And in general, especially when network engineers are working with these, we're not sending dozens of RPC messages all at once and then need to match them up. Usually we send one and we get one back, so we don't have to pay as much attention to that ID field. And so we've taken our CLI command, show VLAN brief, we've converted it into a JSON RPC command or request, and then I can hit the post button here. And this will actually send this live to the device under the hood. And then in just a second, in this response block, we'll actually see the response that came through. And as we can see that it's there. If we take a look at the response, I'll scroll down a bit here, we get back inside our JSON format kind of the information about what we would have seen if we ran this as a CLI command on the device. And so we can see it comes back in this body format. It comes back in the top key here is table VLAN brief. Let's see, brief X brief. And so what we can do now with this data that came back, if we were inside of our code, is we could process through this JSON payload to kind of dive in and see what was there. And so we can see the VLAN ID is VLAN 1. We can see the interfaces that are there. Well, there's the normal VLAN 1. But if we scroll down, we can start to see some of the more interesting VLANs. We can see VLAN ID 100 has VLAN name of management. And then we can see the interfaces that are assigned to that VLAN. And then we can see 101, 102, and so on as they go through. And so now we've seen how we can actually take a CLI command, send that using an API to a device, and then get data back that our script could use. The big advantage, or there's lots of advantages, but the first one that hopefully jumps out to folks as you go through is normally if I were to have used, let's say, an SSH tool or something else to send show VLAN brief, I would have gotten back a block of CLI show data and then had to use some programming tool to parse all that data, whether it's regex or TextFSM or something else to kind of convert that just block of string data into something that I could work with programmatically. By going through this API, I get to work within CLI commands, but I get my data back already parsed an object, which is a huge advantage at this kind of early stage of programmability. I'll pause for a second for breath. Makes sense? Any questions, David?
No, that's great. So just to summarize, you connected directly to a Nexus switch using a web browser. You sent a command, which is a typical CLI command. And did I understand right, it's using the REST API and then it's returning JSON data. Is that correct? So
here's a part where some of the kind of specifics around API terms will come through. It's using NXAPI, which is a bundle of different API capabilities to a Nexus switch. But JSON RPC is the type of API that we use. This actually isn't a REST API. REST APIs, Nexus does offer one. We're going to get to it kind of as we go through that evolution of APIs into the network. But JSON RPC is definitely not a REST API. It's taking a CLI command, sending it away, and then getting back some data, which is different from a REST API. REST APIs, you target some sort of an object. And so I would target a VLAN. And if I wanted to see the list of VLANs, I would send a GET request. You'll notice here the button here says post, because with JSON RPCs, everything is a post request. We post a block of data. In this case, this was the block of data that we posted. What that block of data was a request for some info, and so that's what we get back in the response. And that's how JSON RPC, or as we'll see in a minute, like XML RPC formats work, is everything's a post and you just get some data back. REST APIs is a specific style of writing an API, which kind of works through those kind of get, post, put, delete methods, is very kind of focused in on the URL. So when you're working with a REST API, the URL is how you target the information you're interested in. That's a style of API. So I definitely would not call this a REST API.
That's great. So in other words, the Nexus supports multiple APIs. The one we're using here is, what was it again? The JSON RPC.
Correct.
Nexus
JSON
API,
RPC.
Yeah? Mm-hmm. Yeah, great.
All right. Now over here on the side, you'll see this message format piece. And so over the years, kind of as the APIs inside of NXAPI and as the APIs that Nexus supported evolved, additional message formats started to show up. JSON RPC was the first one that came through. After that, we got XML and JSON. And so what those are is they're kind of Cisco-specific modifications to how this JSON RPC format went through. And over time, some of the differences have kind of eroded away where they don't matter as much. But we'll take a look at them and try to see if we can point out some of the differences that are there. And so again, JSON RPC, I'm going to switch the message format to XML. And so over in XML, so now rather than being JSON focused, this is an XML focused payload. Now we've talked about netconf, which is also XML focused, but this is not, what we're looking at in this case is not a netconf interface. This is what you would typically call an XML RPC style interface. So similar to what we saw with JSON RPC. Now there's a couple of kind of differences that are here. And so I still have that same command, show VLAN brief. We'll see the request window has modified itself. And so now it's kind of formatted itself as an XML payload. Now we want to notice here where it says INS API. So INS, I don't know specifically if this is where it came from, but I always think it ties back to NCME, which is kind of the internal code name of all of the Nexus and a lot of the pieces that were under the hood there in different pieces that went in. And so INS API is here. And so this is a Cisco specific XML style API or RPC API. But under the hood here, it looks very similar to what we saw with the JSON RPC. We see type is CLI show. This is the first bit that's different. So a JSON RPC is just a generic. You'll find JSON RPC style APIs on lots of different types of things in IT, certainly not just networking devices. And so one of the first things that the product team inside of Cisco that was working with NXAPI wanted to offer was some network specific capabilities to the APIs in NXAPI. And so we'll see here the type is CLI show. Over here on the side, we can also see that we've got CLI show ASCII, CLI conf, and then bash. And so when you work with XML, the XML API here, or in a minute we'll see the INS JSON API, we have the ability, these were designed for network devices, the Nexus devices specifically. So we can include the type of command we're sending. So we can say we're sending a show command or we're sending a configuration command. With JSON RPC, it's kind of up to all of those different types of commands just are the same type because JSON RPC doesn't have any concept of a network show versus a configure command. And so this is the first piece, is the ability to kind of distinguish what type of command we're interested in. CLI show and CLI show ASCII, this is easier actually to show when we run it, the differences that are there and describe them. And then we mentioned before when we were talking about the features that Nexus offers is the ability to go into the bash, the bash interface for Nexus. And so we can even use these XML and again the JSON, these are just different formats for the same type of API. We can use it to send bash commands to retrieve information that are there. And so let's send this show VLAN brief, so same command with this API. So I'll send this away. Now the first thing we'll notice when it comes back is the type of data. The data format will be in XML because that's what we've indicated based on the type of API we're using. Now at first glimpse, the output, the stuff that we get here should look fairly similar because it's all based on the same underlying data models from Nexus. And so we'll again see the table, the row, we'll see the VLAN IDs. I'll go down here to one that is a bit more interesting. So we can see VLAN ID of 100, VLAN name is management, the other pieces. So the raw data that we get with the XML API is basically the same as JSON RPA, the JSON RPC API. Some of the differences and why it's there, if I scroll down here, we can see we also get back what was the exact input command that was sent, and we get message code information that's there. Now this command succeeded successfully, which means I got a success message. But one of the big advantages of the XML and the JSON APIs from Cisco specifically versus the JSON RPC are error messaging. If you get an error in a command with a JSON RPC, you get a fairly generic JSON RPC error. But because these were designed for use with Nexus, error messages with these two APIs, the one we just went with, which was XML, or if I switch over to JSON and send the same one, these will have more interesting error messages should they come through. And so in this case, this is, again, the same data we just saw, but now it's been formatted in JSON format because we switched over to JSON. And down at the bottom, actually, where is it up at the top in this one? Yeah, we get the code, the message and the code status that's there. And so if I were to mistype this for an example and I'll do VLAN DE brief, which is not a command at all, we can see I get CLI error, I get input CLI command errors, I get error messages that will make more sense from a networking perspective as they go through. Does that make sense?
Yeah, that's great. So just to, again, reiterate, the XML and JSON that you're showing us are using the INS in semi. In other words, it's a Cisco proprietary API. Is that correct?
Yep. Yeah. So exactly. So these two, XML and JSON, they're the same style API. It's a data format piece that's different, and this is something that was specific to Nexus that was designed, and it was designed to allow the ease of use of CLI commands, but to add a little bit of extra knowledge around error messages and some of the transactions and processing and type of commands that you might want to send.
I don't want to jump the gun, if you like, so-called, but how many APIs does the Nexus switch typically support? Because, I mean, it looks like there's quite a few here.
There are a lot. I honestly have never counted them. We can try to keep count as we go through, and some of it might come down to what we count as an API versus a tool in some of the debate. It's one of those cases where sometimes I feel like there's too many, but again, different engineers have different enterprises have different requirements for their APIs and what they're after. And what's nice about working with the APIs in Nexus is what we're starting at here is we're working with CLI commands, which is what every network engineer is comfortable with already. And you can immediately jump in and start taking advantage of programmability. But as we'll see kind of as we go through our discussion this morning and on the video, eventually you may want to get out of dealing with CLI commands and work with a REST API and objects, or transition into a standard like netconf. And the Nexus platform offers those as well. Or if you want to use a DevOps tool like Ansible or Puppet or Chef, Nexus supports all of those as well. And so it's a nice broad spectrum, which is one of the strengths that Cisco has long had, which was trying to offer a broad spectrum of capabilities across. And Nexus is a great example because it does have so many different variations across this area as it goes in.
And I also suppose it's a historical thing, isn't it? Where
to some extent,
they perhaps started with one. Sorry, go on.
Oh yeah, we were talking over, but to your point, it's a historical preference. As I mentioned, I like Nexus because of this ability for me to describe kind of the evolution of SDN and APIs in the network over time, and as demands and requirements and expectations changed. Because a lot of this APIs into the network stuff is not all that old. I mean, we're talking 6, 7, maybe 10 years if you're at the very, very early side of it. And that's not all that long in the lifespan of kind of networking in general and the capabilities that are there. So we get to see a lot of kind of that evolution here in the platform.
So just for the cynical guys, playing my cynical network engineer story again.
Yep.
It does support REST and it does support netconf. So if guys want to use those, that's available. But for guys who are starting out, we have these CLI kind of hybrid type interfaces that we can use.
Yep. And that's usually how I describe it is a great starting point. And honestly, network engineers, and David, we've talked about this before, when you've done your network automation or your Python discussions, you're often just using that tool to wrap up CLI and send it away. So you're using NetMiko or one of these other libraries to do that. What we have here is the same basic idea. Is I can wrap up some CLI in an HTTP request. And some of the benefits are now, rather than having to use SSH as the transport protocol, which isn't the greatest for that type of a use case, or having to self-parse the data that comes back, we get that from the API that's available.
That's great.
Now, the one thing I did want to point out before we kind of continue on our API journey here is this difference between CLI show and CLI show ASCII. So I'll send this one again. And so we'll notice the thing that I want to point out is the data that came back from the CLI show is it's all parsed. In this case, it's all parsed inside of XML payload. So I could jump directly in and get access to the VLAN ID or the VLAN name or the interface IDs that are in part of it. Now, let's say you were moving in and beginning to use this API, but you already had a whole bunch of scripts from using, let's say, NetMiko or pexpect or one of these other tools, and you already had written the code to parse the CLI show command output format. That's what CLI show ASCII is useful for. Is if you've already written code to parse it, and you don't want to have to go rewrite that code to take advantage of the already parsed data, is you can use CLI show ASCII, and now the data that comes back is the exact same format that it would come back from a CLI command. This is only useful in that type of a use case, is where you've already written code and you're just trying to transition from using an SSH transport to something like this, and you don't want to rewrite the processing code. In that case, well, fine. We'll give you the raw CLI show data just as you normally would see it. And if I scroll down, you'll see we get the show data that's there. And so that's the difference in why we have this CLI show versus CLI show ASCII, is for those use cases where you actually do want the raw, unparsed data as it comes through.
That's great. It's also nice for learning, I think.
Yeah, absolutely.
You can see, because sometimes CLI show, it's for a machine. It's not for a human. So this is nice to see, the human equivalent, if you like.
Exactly. And so we'll flip over here. I'm going to flip in just to kind of move along. We'll see that the JSON version also has CLI show ASCII, and then CLI conf. And so as you can think of, CLI conf would be for sending configuration commands. And so this kind of, when you use the CLI conf, then you'll see that it shows up over here under type. CLI conf is our type. This is going to send configuration commands. It's automatically going to put this into config mode, so you don't have to send a config T. All of that's there. And you can see that we've got some error action options that we can go through. And so do we want to stop on an error? So if we send a bunch of commands and the device hits an error state, we try to configure an interface that doesn't exist, or we miss something in there. Do we want it to stop? Do we want it to continue? Or do we want it to roll back? So stop would just be get to that point and stop. Continue would get to that point and then note that there was an error on that configuration line, but go ahead and send the rest of the commands that are in the transaction. And then rollback would say, hey, if I get to an error, go undo everything that was already specified in there. So you get some nice kind of choices that are there. I'll just pick this first one, stop on error. We can see the rollback configuration gets changed. And I'll put in here some commands to configure a new interface. So we'll do VLAN, we'll say 3001, name, demo VLAN, and that's probably enough. And so we can see the way that the format goes through is this input line gets kind of semicolon separation of the configuration commands that I want to go ahead and send. So we can say VLAN 301, name demo VLAN, output format will be JSON, and our configuration, our rollback strategy, stop on error. So if I send this away, we can see that I get line by line status messages, or command by command. So this first command had a 200 success. The second one was a 200 success. And there was no specific output that came from those configuration commands because they just kind of run as they go through. And to prove this out, just to kind of stick with our APIs, and we'll do this in a couple of ways, I can switch back to show VLAN brief. I don't want CLI conf because that is not a configuration command. We'll do show array or show ASCII because that'll give us the ability to see the in the nice format. Show VLAN brief. Oh, actually, this is a less nice because it actually sticks it all into one line. You see that over here? So in XML, it actually formatted it in the new lines. We can see here in the body, this /n is the indication of where a carriage return would happen. So if I actually were to copy all of this into a window and process it and print it out, this is where the new lines would go. So that's kind of ugly. I'm going to switch back to just CLI show so that we can see it. In this case, this is actually more human readable as the actual JSON data.
It's nice to see that, though.
Yeah. And if I scroll down, there we go. There's VLAN 3001 that we just added. So we've added it. And then for the CLI folks that are there, if I do a show VLAN brief right on the switch, we will also see that 301 was added. So we've kind of seen it all across the way. So using the APIs to retrieve and send some information. Make sense?
Yeah, that's great. It's nice to see this.
Yeah, perfect. All right. So when we turned on NXAPI, what I like to talk about is it actually turns on under the hood two different types of APIs. It turns on what I call, and you'll see this in some of the other documentation, so it's not just Hank's name for it, but NXAPI CLI, which are a set of APIs that let you send CLI commands over an HTTP API, and we've seen all three of those, JSON RPC, XML, and JSON. Those are all kind of NXAPI CLI. And then there's also NXAPI REST. And so when I told you before that what we were looking at was not a REST API, Nexus does offer one, and it's called NXAPI REST. And it's enabled along with feature NXAPI. So you kind of get all of them turned on at the same time because they all kind of build on top of that HTTP piece. And we can see here in our sandbox, NXAPI REST shows up. Excuse me. And we can see command types of CLI and model. Excuse me. What we'll find is we'll look here in the developer sandbox, but honestly, the NXAPI REST, because it's not designed as a CLI-based API, it's actually designed as an API, a true REST API that's targeting specific objects under the hood inside of the Nexus switch that you're working on. So an object would be like an interface would be an object, or a VLAN is an object. When you're working with NXAPI REST, the CLI is kind of irrelevant. You're not dealing with a CLI command. You're saying, I want to target that specific VLAN and I want to make a configuration change, or I want to make just retrieve some information about it. And you're not working with CLI. You're sending payloads, or you're requesting information that's through there. But the developer sandbox gives us a way to kind of work with CLI commands and do some of the conversion that's there. And so I actually didn't test this one in advance, but let's see what happens if I try to convert show VLAN brief. Now, see, some of that's the CLI to objects. Not all of them were kind of written in, because each one of these CLI to objects would have to be coded by the developers of the sandbox. And so they've done a few of them to make it easier to see kind of what the objects are. I think show hostname works though. No, I'm going to be here for all day trying to figure out which one.
So Hank, sorry, I don't want to change the sort of the track, but just before we go any further, this developer sandbox that we're talking about, is that a DevNet sandbox, or is this something that runs on the all Nexus switches type thing?
That is a great question, and certainly an area of easy confusion. So what we're looking at here, this NXAPI developer sandbox, is not specific to DevNet sandbox. It's actually, it's a developer playground or sandbox, which is why the name is so commonly pops up, that runs on the Nexus switch that's there. And so the Nexus switch we're using happens to be in a DevNet sandbox, but if you had a switch in your lab, or if you downloaded the Nexus 9000 virtual switch and you ran it on your own workstation or someplace in a lab, you could get access to this developer sandbox just by turning on feature NXAPI. So it's a feature of the Nexus switches that support NXAPI. It has nothing specifically to do with DevNet sandbox, but obviously you can take advantage of it inside of a DevNet sandbox that has a Nexus switch. So it's just this word sandbox actually pops up in a lot of different places, depending on context and kind of who's using it with what's there. But yeah, definitely a confusing one that goes through. We're kind of playing in the NXAPI developer sandbox while using a Nexus switch from a DevNet sandbox. So it's kind of like sandbox in sandbox. So
that makes sense. So a curveball question. So if I purchase Cisco Viral you get a Nexus 9000 virtual image. I could use that for something similar to what you're doing here type thing. Is that right?
Yeah, absolutely. Yeah, any Nexus switch that supports NXAPI, and so feature NXAPI, and it's been on Nexus switches since version 7 something, and you'll find feature NXAPI on Nexus 5000s and 7000s and 3000s and 9000s that are there. Now, this is actually a decent place to go through this. So the APIs that we've talked about so far, the NXAPI, CLI APIs, so JSON, RPC, XML, and JSON, those are available on kind of the full spectrum of Nexus switches. So Nexus 5000, 6000, 7000, 3000, and 9000. Where we're headed next, this NXAPI REST is actually specific to the Nexus 3000 and 9000. You won't find the REST API element on the older generations of switches, the 5, 6, and 7000s. NXAPI REST is specifically on the 3000 and 9000 series Nexus switches on that. Does that make sense?
Yeah, that's great to know. Yeah, brilliant.
Perfect. So as I mentioned, so NXAPI REST comes out, is enabled on the 3000 and 9000 switches when you turn on feature NXAPI. And we can see it shows up here in the sandbox, but it's not, I don't think the developer sandbox it was never intended for working with NXAPI REST. They've added bits of it here, and you can try to plug in different commands to go through. But frankly, if you want to work with the NXAPI REST, I actually think there's better places there's a better tool that's embedded inside of the Nexus to go through on there, which is what we're going to go to next, which is called Visuri. So I'm going to switch to a new tab here. And so I'm back at the same IP address of my switch, but I've added in visuri.html. And I know it's tiny on my screen. Maybe David, you can put like a big text window up over the video when you go with the URL that's there. But it's just visuri.html. And then I probably have to log back in on this one too. Yeah, let me wait here. There it goes. And so the login again is just the credentials. So admin Cisco 123. And so what we're looking at here is a REST API object browser tool. And so as I mentioned, when we move from NXAPI CLI, so the ones we had been looking at, to NXAPI REST, we're leaving CLI and CLI commands and CLI constructs behind. And now we're actually getting a look and the ability as network developers to touch directly into the actual operating system that's there, into the objects that are under the hood. And so we're walking our way through the objects that are there. The objects inside of the object model for NXAPI is modeled after a tree. So there's parents and children, and everything kind of lives underneath this top system that's here. And so we can see it's called sys. DN in this case stands for distinguished name. And so a distinguished name is every object has a very unique name that targets that specific object that you're after. And everything kind of builds on top of the sys that's there. And so with the REST API, you can kind of walk up and down this tree to look at different objects that are there. Now, we don't have time on the amount of time. We could do dedicated several calls just to NXAPI REST. And if there's interest, we can certainly do more. I have no problem diving into them. But just to show kind of how some of these pieces work, we're going to look at, again, those same VLANs that are there. And so the NXAPI REST API and the objects were built to mimic the ACI object model that's there. So if anybody's worked with ACI before, the layer 2 concept inside of ACI is called a bridge domain, sometimes abbreviated to BD, bridge domain. It's a layer 2 construct in ACI. Now, when you take that layer 2 construct and you bring that back to kind of classic network concepts, a layer 2 construct is a VLAN. And so that's why here the VLAN object inside of Nexus is called L2BD. And this was, again, designed for two reasons. It's based on similarity to the ACI model, but it's also built to try to ease transition from folks moving from a non-ACI data center to ACI by saying, hey, my bridge domains are going to be the same types of stuff in both sides. And so what I can do now is search for all of my L2BDs. I can run this query. And this will show me all of the VLANs, or what's called here by object L2BDs, as a REST API that goes through. And so now when I scroll down, we can see here VLAN 100, right? Where's its ID or its name? There it is. So the ID number here, VLAN ID 100, it's encapsulated as VLAN 100. Nexus supports VXLAN encapsulation as well. So if I don't have that configured, but if we did, our encap might say VXLAN for different types of bridge domains. We can see this is a classic Ethernet as opposed to fabric path as it goes through. And then somewhere there should be the name. Oh, yeah, BD Oper name. So this would be the name of the VLAN is management, MGMT. If I scroll down, we can see another VLAN that goes through. So this one is our prod VLAN for its name. And we can see the VLAN 101, and we can see the ID. Now here in the middle, this DN field, as I mentioned, every object, and this is similar with any REST API. So inside of a REST API, what you're targeting are objects. And every object needs to have a unique name of that object. And so the unique name with NXAPI REST is distinguished name, DN, and it kind of builds through the tree. So as I mentioned, everything starts at sys, that's the top level of the system. And then we were talking about bridge domains, BDs, and this particular object is called BD-VLAN 101. And so that's the name of this object as it goes in. Now, I want to kind of look at the difference between the types of calls that you see when you're working with NXAPI REST versus NXAPI CLI. So I'm going to switch over to Postman so we can actually see how we would make this call, this REST API call, rather than through the Visuri tool. We're going to look at it as a raw API as it goes through. So what I've done now is I've switched over to Postman. We've talked about Postman on previous videos, so if you haven't seen those yet, Postman is a freely available REST API client for developers or anybody that wants to work with REST APIs, and lots of features to make it easier. And so what I'm using it here is using it as an API tool to make an NXAPI REST call. So up here at the top, we can see kind of how the request is built. Now, as I mentioned, when we talked about NXAPI CLI, when I was trying to retrieve information, it was still a post because it wasn't a REST API. But NXAPI REST is a REST API, and so to retrieve information, it's a GET request. And so we can see GET right here. The URL is how we identify what we're interested in. So it's not a CLI command. I put in the actual address of the object I'm interested in. And in this case, the address we're looking at is here at the end of the API call. And so it's the distinguished name. And so as mentioned, everything builds from sys, the top level system. And so sys/BD to indicate we're interested in bridge domains, which are the VLANs with NXOS. And then the specific VLAN we're interested in. So in this call, my default was BD, and then we can see VLAN 1. I'll change this to VLAN 3001 for the one we had just created with NXAPI CLI. And then at the end, this .json with NXAPI REST uses a different style of identifying the types of data formats. If you've done work with other REST APIs, you may be more familiar with using headers like content type and accept headers. With NXAPI REST, you add .json at the end to indicate JSON. If I was interested in XML, I could just do .xml. And so I've now crafted my request for a particular API that I'm after. And then we could send this away. Now, before I send this, I actually have to authenticate to the device. REST APIs, in general, have lots of different ways you might authenticate to a device. Sometimes you just include the username and password as kind of an encoded header. Other times you need to get an authorization key and include that as a header. The way that NXAPI REST works is actually similar to how ACI works, which is where you have to request a session token and cookie. And so this tab over here is how I actually request and log in so that I can make this request that goes through. And so the API, you send an API call off to this AAA login.json. What you provide is the username and password. And so you send that as part of the body of this post request. We can see name and password keys. These double curly braces are Postman variable substitution. And so over here, if I look at my variables, we can see username and password are stored. And then those just get substituted into this body. And so I can reuse this API call inside of Postman with lots of different types of devices should they change. So I'll send this away. I get a 200 OK back. And then down here, I can see my token. Now that token's actually included inside of an HTTP cookie, so I don't have to kind of copy and paste that between requests. But now that I've got a cookie, I can come back over here to my request where I was going to say sysbd VLAN 3001, and I can send this away. And so now we get our data back. Now in this case, you'll notice this isn't laid out in that same table format that we saw with NXAPI CLI options that went through. We're actually getting object attributes that go through, and in our case here, they're represented in JSON. And so we can see that this is a layer 2 BD. It has a set of attributes. We can see its name, its state, all of the information. And actually, the data that we see here is the same as what we saw inside of the Visuri output, but now it's being shown that we captured this as part of our own API call as it went through. If I wanted to change this VLAN that was there, let's say I wanted to update its operational name as it went in. With REST APIs, they're designed around this method. So a get method lets us retrieve information. Post, put, and delete are the other common ones we would use to either update or get rid of them. And so I'm going to, up here in Postman, I'm just going to duplicate this column or this tab here and say, okay, I'm going to go ahead and instead of get, I'm going to say, let's say we're going to do a put. And so I'm going to update some information. Now, because this is a put, I would have to send a set of body that I want to update. Now to do that, I'm going to cheat a little bit so that I can grab some details because I had a one over here I'm going to copy from. Where is it? Post. Copy this. And so here I'm on put, and I'm just grabbing a sample details. And so the data that we're going to send here, again, it's a layer 2 BD, attributes. Now we're not going to change the in cap on this one because I don't think you'd actually be able to change the encapsulation, but I should be able to change the name. And so we'll change this to updated VLAN. And then we'll cross our fingers and see if this one works.
Before you run that, Hank, can we just check on the CLI of the Nexus? I trust you, but just in case someone doesn't trust you.
Yeah, so we'll do a show run VLAN 3001. So right here we can see VLAN 3001 name demo VLAN. And let's see if this lets us update the name. Send. All right, so I got a 200 OK back. So when you use REST APIs, 200 OK, that's a success message as it went through. Now the body of data that came back doesn't tell me anything because I just sent it an information to update. As far as a REST API is concerned, the fact that it told me a 200 OK should be satisfactory enough. If I wanted to retrieve and see the new name for that, we could go back and send the GET request again, or we can go over here to our CLI where we sent it, and we can show run VLAN, and we can see again, look at that, it actually worked. I didn't even practice that demo before our video. VLAN 3001, name updated VLAN as it went through. So we've been able to kind of update them as they go in. And so that's one of the things that's really nice about REST APIs is the fact that the same address, and so here in this put, it's the same exact URL. It's the same address for the object, but we're just flipping the method from get to put because we want to update it. If I wanted
to see your get again, just to reiterate the point that it's changed?
Yep, absolutely. So if I send this one here, we can see now our BD oper name has been changed to updated VLAN as it went through.
Yeah, I think that's great. I mean, we can see it through the CLI, which is what a lot of guys would trust as or see as the most trustworthy source of information. But we can also see it through the REST API.
Yeah,
it's good to see it.
As we finish out kind of our demo here on the REST APIs, we'll show the full life cycle. So we originally created this VLAN with NXAPI CLI. We've retrieved it using NXAPI REST. We've updated it using NXAPI REST in the put. To delete this, let's say I was done with VLAN 3001. It's again the same address. We simply change the method from put to delete, and we send this away. And so I send that. I get a 200 OK. Again, that tells me things are good. No data back. The data, if there was an error, is where we would actually see data coming through. It would be informational stuff. But everything was successful. And if we check our CLI and try to run our command, we'll see that no VLAN is returned here when I try to run the command, so I get no data. And if we try to retrieve it using our GET request up here, I get I get a 200 OK. So my request was successful, but we'll see that no data was actually returned as it went through. So I didn't get an actual VLAN that came back.
That's great.
Perfect. All right, let's see. So one last thing we'll kind of do as a teaser, because I think there's more time and there's actually quite a bit more we can dive into with Nexus. But because I told you we were going to show the bash, we'll kind of use this as a teaser for our next video as we come to the end of our time this morning.
That'd be great.
And I'll jump back over to my switch. And so if you've got any experience with Linux outside of networking, if you've used Ubuntu or CentOS or any other platform that's there, you've probably played around with bash that's there. And so again, I've turned on bash by doing feature bash. I think it was, what was it? Bash shell, I think, show run, include, oops, feature, which one was it? It was bash shell. So feature bash shell. Now, feature bash shell doesn't turn on bash under the hood. Bash is running and Linux is running no matter what, because that's what Nexus needs. Bash shell gives me the ability to do run bash. And so now we'll see my prompt changed from SBX 9KV for the hostname prompt to bash 4.3. And I've kind of, I don't want to say I've exited NXOS because it's still running. It's like the switch is still doing its switching thing, but I've kind of pulled my client out of the NXOS application interface and entered into Linux. An example that I can think of might be if you connect to a Linux server that's running, let's say, MySQL, which is an open source database engine. You can get access to a MySQL CLI where you're sending MySQL commands, and then you can exit out of the MySQL CLI and get back to the underlying Linux. We've kind of done that same thing, but rather than starting at bash and entering NXOS, we went into NXOS, and now we've kind of jumped from NXOS into the bash piece that's there. Does that make sense, or did I make it more confusing?
Yeah, I like to say you've dropped down into bash or into Linux, haven't you? You've dropped down from the application to the kernel.
And so we're there. And so you can do lots of things when you're inside of the bash capabilities that are here. I can do a PWD to see that I'm in boot flash home admin. I can do ls-l, and we can see that there's actually not much there. But if I look at boot flash, we can see the contents of the boot flash. So we're still on the same switch. We've got access to the same basic types of pieces that are there, but now we're working through here. There's lots of stuff you can do from within bash. One of the interesting ones for me as a network engineer is to actually explore and look at networking from the Linux perspective on the switch. And so when we're on NXOS or you're on even iOS XE, we're used to working with commands like show interfaces, show IP interfaces, and all those pieces. Those interfaces, Ethernet 1.1, 1.2, all of those, they're represented as Linux interfaces on the underlying switch that's there. And so if I do a Linux command of IP link, and it's going to show us a ton of detail because there's lots of interfaces on this switch, so I'm going to hit it, and then we'll kind of let it run. I'm going to scroll up a little bit to some of the earlier ones. So this is a virtual switch, and as a virtual switch, it's got, I think, 100 or so Ethernet interfaces that are on it. I'm going to scroll up here to some of the interesting bits. So here we can see details about Ethernet 1.1 that's on there. And so these are the Linux link details. And so the IP link command in Linux kind of gives me layer 2 pieces. So I can see the MAC address that's assigned here. Up above, you can actually see that we also see our VLAN interfaces pop up. So there's VLAN 100 I highlighted, 101 that's above it. And so now I can see these inside of the underlying Linux. If I was interested in IP information, I could do IP ADDR for IP address. And rather than seeing all 172 of them, I'm going to do show device, and we'll say VLAN, I think it's capital V, VLAN 101. And so now I can jump in and actually see like the Linux state of these interfaces as they go through as well. And so again, it's not like it's a Linux virtual machine on the switch or a Linux container. Nexus actually supports that type of model as well. But now we're actually on the actual underpinning Linux for this switch and can see information about the switch kind of at the Linux device level rather than just through the NXOS. And there's not every engineer needs that type of visibility or has use cases for it, but it is, when they do pop up, it is kind of nice to see that those capabilities that are there. Or if you're working on Linux networking skills, you can kind of use those same skills here in kind of your core networking perspective as they go in. Questions?
No, that's great. So you said this is a teaser, so you're going to show us more Nexus stuff perhaps in the next call?
We will. I never know how long it's going to take us when we get into one of these calls to talk through, but there's plenty more. So I think some of the stuff we can dive into is we'll finish through some of the interfaces that are available on Nexus. So we've talked about netconf before. I want to take a little bit of time, talk about netconf using with Nexus as well, because that's supported. So we'll look at those. I want to spend a bit of time on what the bash capabilities offer us here, and things like running Docker containers on our switch, different application capabilities that are there, and different pieces. So I think we've got plenty more to do another video here to dive into more of the Nexus stuff.
Yeah, it'd be great to see Docker running on a switch.
Mm-hmm.
That's something that's like a bit out there. It's not something you typically think about. So that'd be really good to see.
Yeah.
Yeah. So Hank, I mean, just to wrap up, thanks so much again for spending so much time with me and explaining all this new stuff. I mean, your knowledge is amazing. So really appreciate it. Thanks.
No, absolutely. Thank you. And I promise we will get Docker on a switch in our next call. We were going to do it today. We just ran out of time. So folks got to stick back. Same, what are we going to do? Same network time, same network channel.
Yeah, definitely. Yeah.
Absolutely.
Great, Hank. All the best. Have a great week.
Thanks, David. Talk to you soon.
Cheers.